Today we are going to discuss 2.3 absolute values, and we are going to cover 2.3a and 2.3b. Okay, for today. So let's go through the learning outcomes. Okay, so for 2.3 absolute values, okay, so the first learning outcome is to state the properties of absolute values as follows. Okay, so but before we discuss these properties, so first thing first, we have to define absolute value. Okay, what is absolute value? So absolute value is basically distance. Okay, so absolute value is a distance, okay, from zero number along the real number line. Okay, so that means when we define the absolute, so we have to know that the numbers have to be real numbers. Okay, so okay, if we recall topic 1, okay, especially subtopic 1.2, so we may discuss the complex numbers, right? Okay, when we discuss complex numbers, so we do have the modulus symbol here. Okay, so this one is called as modulus of complex number. Okay, so absolute values is basically modulus of real numbers. Okay, while for 1.2 we discuss modulus of complex numbers. So for example, if you put a complex number inside, so we have modulus of complex number square root of a squared plus b squared. Okay, while this one for this topic we discuss 2.3 absolute values of real numbers. Okay, so this is the difference. This one is modulus of complex numbers, okay, while this one is absolute values of real numbers. Okay, so if we go through the properties, so basically we have 6 properties altogether. Okay, so in order to prove these properties, we may simply substitute any values inside. Okay, so the first property says that if we have absolute of A, it is greater or equal to 0. Okay, why? Because just now we defined that absolute value is a distance. So it does make sense that absolute of any number must be greater than 0. Okay, but if you have absolute of 0, then it will become 0. Okay, then for this one, for the second property, absolute of negative A is equal to absolute of A. So if we plug in a value inside, so let's say if you have absolute of negative 5, okay, so we know that it will become 5 because again we measure the distance or the length. Okay, and same thing here, if you have absolute of 5, so it is also equal to 5. Okay, so this defines the property, the second property. Okay, what about the third one? So the third one is if you have absolute of A plus B, it is equal to absolute of B plus A. So again, if you plug in a value, so let's say if you have absolute of 2 plus 3, okay, so we will get 5. Or absolute of 5, then we will get 5. Okay, then same thing here. If we swap the position, so we have absolute of 3 plus 2. So again, we will get absolute of 5, which is also equal to 5. Okay, so that's the third property. Okay, then what about the fourth one? Okay, if you have absolute of A minus B, it is also equal to absolute of B minus A because actually we are measuring the distance, the distance between A and B. So it doesn't matter the the difference will be the same. So that's why the values are equal. So for example, okay, if you have absolute of 3 minus 2, so it will become absolute of 1, which equals to 1. Okay, let's say if you have absolute of 2 minus 3, so it will become absolute of negative 1, which is equal to 1. So this proves the fourth property here. Okay, then what about the next one? Absolute of AB is equal to absolute of A times absolute of B. Okay, so let's give an example. For example, if you have absolute of 3 times 2, okay, so we know that this will become absolute of 6, which is equal to 6. Okay, then let's say if you have absolute of 3 multiplied by absolute of 2. So we know that this will become 3 times 2, which is also equal to 6. So this also has proven the property. Okay, then what about the last one? Okay, the last property here. Okay, so we have this property. If you have absolute of A over B, we can split into absolute of A over absolute of B. Okay, so let's do an example. So here, if you have absolute of 5 over 2, okay, so this will become 5 over 2. So the distance here is 2.5. Okay, then what about if you have absolute of 5 divided by absolute of 2? So it will become also 5 divided by 2. Okay, because we know absolute of 5 is 5 and absolute of 2 is 2. Okay, we have covered A just now. So now let's cover the second learning outcome. So the second learning outcome says that we're going to solve the absolute equations of these forms. Yeah? Okay, so then, before we discuss on how to solve these absolute equations, so now let's define the absolute values. Okay, just now we discussed the properties. Okay, now we are going to discuss the definitions of absolute values. Okay, the definition of absolute value. So first definition says that if you have absolute of x, it is equal to set or square root of x squared, which is equal to positive of x when x is greater equal 0, and it will become negative of x when x is less than 0. So that's the first definition of absolute value. Okay, now in order to discuss the absolute equations, okay, so basically we have this absolute equation of these different forms. So we are going to discuss this, okay, 4 different forms of absolute values. Okay, but first thing first, we have to know this definition. Okay, if you have equation of absolute value, okay, so let's say we have absolute of x equals to a value, so we have to define this, okay, x equals to a or x equals to negative a. Okay, so now in order to use this definition, okay, so you see if you have absolute equation where absolute on one side, okay, like this one, so we are going to use the second definition here, okay, whereby we need to split into 2. If you have absolute of ax plus b equals to c, so we may solve this absolute equation by using the definition and split the equation into 2. So we have ax plus b equals c, or ax plus b equals to negative c. So let's try to see an example. Okay, so if you have absolute of 3x plus 5 equals to 3, so we may solve this absolute equation by using the definition. So we split into 2, so 3x plus 5 equals to 3, or 3x plus 5 equals to negative 3. Yeah? So because based on the definition, we have one positive and one negative. And then we just solve the linear equation as usual. So we have 3x equals to, we bring 5 to the right, so we have 3 minus 5, which is negative 2, and x equals to negative 2 over 3. And we have here, for the second equation, 3x equals to negative 8, and x equals to negative 8 over 3. Okay, but then we cannot simply stop here, so we have to leave the answer in solution set. So what do? We finalize the answer, hence x is equals to, okay, we may arrange the answer. Okay, we put the lowest value first, followed by the next value. Okay, but usually the arrangement does not matter. Okay, but the best is if you can arrange the answer. For the second type of equation, okay, if we have absolute of ax plus b equals to cx plus d. So if you notice, the difference between the first and the second type is that we have a linear function on the right hand side. So we have this variable x, okay, without the absolute. So how to solve this absolute equation? So again, we split into 2 by using the definition. So it will be ax plus b equals to cx plus d, or ax plus b equals to negative of cx plus d. Okay, so now let's see an example. Okay, we have example here. If absolute of x minus 4 equals to 2x minus 1. Okay, so please bear in mind, so this is a linear, and we have a variable x here. Okay, so how to solve this absolute equation? So again, we split into 2, so we will have x minus 4 equals to 2x minus 1, or we have x minus 4 equals to negative of 2x minus 1. Okay, so please bear in mind, okay, we have to put the bracket here so that it will become the negative of the whole thing here. So now again, how do we solve this? So we solve one by one. Yeah? So we have this. So for example, we bring the negative 1 to the left and we bring the x to the right. So what do we have? We have minus 4 plus 1, which is 3, negative 3. And 2x minus x is x. So we rearrange, so x equals to negative 3. And here we have x minus 4 equals to negative 2x plus 1. So we bring the negative 2x to the left and we bring the negative 4 to the right. So we will have 3x equals to 5 and x equals to 5 over 3. But then, okay, if you see there is a reminder here. Okay, we have to check answer. Okay, so in order to check this answer, so we are going to substitute into, okay, the equation. Okay, so in order to see whether the value satisfies the equation or not. So we do this checking step. Okay, so now we do for x equals to negative 3. So we substitute, okay, on the left hand side. We have absolute of negative 3 minus 4 equals to absolute of negative 7, which is equal to 7. But if we substitute into the right hand side, so 2 times negative 3 minus 1. So we have negative 6 minus 1, which is negative 7. So we can say that left hand side in terms of values is not equal to right hand side. So we reject this answer. Okay, then let's do the checking step for the second value. So we have x equals to 5 over 3. Okay, so by the way, this is the right hand side, yeah, for the previous one. Okay, then let's substitute 5 over 3 into the equation. So we have absolute of 5 over 3 minus 4 equals to absolute of negative 7 over 3. Okay, and then we have 7 over 3. Okay, what about the right hand side? Okay, so we do it here, right hand side. So we have 2 times 5 over 3 and then minus 1. So we have 10 over 3 minus 3 over 3. So it will become 7 over 3. So since left hand side equals to right hand side, so we may accept this answer. Okay, now if you have the third type here, okay, so we have absolute of rational function equals to a value here. So we may solve this rational equation by, again, using the definition. So we have, let's say, if we have absolute of ax plus b over cx plus d, so we split into two equations. So we have ax plus b over cx plus d equals to e, or ax plus b over cx plus d equals to negative e. So now let's see an example. Okay, if we have absolute of two x over x plus 1 equals to 4. Okay, so we may solve this absolute equation by using the definition and split into two different equations. So we will have 2x over x plus 1 equals to 4, or 2x over x plus 1 equals to negative 4. So now we solve, okay, one by one. So we will have 2x, and we cross multiply, so we have 4x plus 4. Okay, and we bring the 4 to the left, so we have negative 4 equals to 2x. Thus, x is equals to negative 2. And then for the second equation, we have 2x equals to negative 4x minus 4. And we have 6x equals to negative 4. And we have x equals to negative 2 over 3. Okay, and because we have this constant 4 without the variable, so we don't have to check the answer, and we can simply finalize the answer in set form. So x double dot x equals to negative 2, negative 2 over 3. Let's see the fourth type. If you have absolute equation, but then, okay, now if you realize, okay, this one is a quadratic expression. Okay, so absolute of quadratic equals to a value. So we can solve this absolute equation by using the definition. So one will be positive of d, and the other one will be negative of d. And also don't forget to put the or word. So now let's see example 4. Okay, so if we have absolute of 2x squared plus 3x minus 35, so it is equals to 30. So how to solve this absolute equation? So we split into 2. So 2x squared plus 3x minus 35 equals to 30, or 2x squared plus 3x minus 35 equals to negative 30. Okay, so again, we have two equations here, and we solve one by one first. So we have here 2x squared plus 3x minus 35 minus 30 will give us negative 65. Okay, so now in order to solve this, so we may factorize. Okay, whenever we have quadratic equation, make sure we show either factorization or completing the square, or by using formula. Okay, so because this we can factorize, so we factorize into two different factors. So we have 2x and x. Here we are going to have 13, and we are going to have 5. So in order to get 3x, here we put positive, and here we put negative. So x is equals to negative 13 over 2, and x equals 5. So here we solve this second quadratic equation. 2x squared plus 3x minus 35 plus 30 will give us negative 5. So we factorize. So we have 2x and x here, and we put 5 and 1. So in order to get positive, 3x is plus 5 minus 2. So we have x equals to negative 5 over 2, and x equals 1. Okay, so because we have only real number, okay, without a variable, so that means we don't have to check our answer. So we can simplify, okay, finalize the answer in set form. X double dot x equals to negative 13 over 2, negative 5 over 2. Okay, we arrange the numbers in ascending order, and lastly 5. Okay, now for the last type of absolute equation. So if you have absolute on both sides, so what must we do? Okay, first we use the definition. So where can we find this definition? So this is actually the definition. Okay, so the definition is that if we have absolute of x, so it is equal to square root of x squared. Okay, then the second step, what do? We square both sides. So let's see an example. If we have absolute of ax plus b equals to absolute of cx plus d, so by using this definition, okay, we are going to transform absolute of ax plus b to be square root of ax plus b squared. Okay, and we do the same for the right hand side as well. And because we have set on both sides, so in order to get rid of the set, we just square both sides, and then the set will be gone. So we just solve the quadratic equation. Yeah? Okay, so now let's see an example. So if we have absolute of 6x minus 5 equals to absolute of 3x plus 5. Okay, how to solve this equation when we have absolute on both sides? So again, we use the step, we use the definition. Here, absolute of 6x minus 5 will be square root of 6x minus 5 squared. And then we do the same for the right hand side. So we have square root of 3x plus 5 squared. And then in order to get rid of the set, we simply square both sides. Okay, so by squaring both sides, so we are going to eliminate the set. So we have 6x minus 5 squared equals to 3x plus 5 squared. Okay, and then we square one by one, so we have 36x squared minus 60x plus 25 equals to 9x squared plus 30x plus 25. So we bring everything to one side, so we are going to have 27x squared, and then minus 60 minus 30 will give us negative 90x, and then the 25 can be cancelled out. So we factorize, so we will have 9x here, and we will have 3x minus 10. So we have x equals 0 and x equals to 10 over 3. Okay, in this case, because we know that both sides are positive, okay, they represent the absolute. Okay, so we don't really have to check our answer. So we simply finalize the answer. X double dot x equals 0 and x equals 10 over 3.